Today we're going to be graphing two variable inequalities. So this goes along with our goal that we'll be able to solve inequalities in mathematical and real world situations. So there are some general steps that we're going to be solving or using to solve and graph two variable inequalities. The first one is to get into y equals mx plus b form. So that's going to get us into our line formula. Then we're going to graph the boundary line. So we're going to plot the y-intercept first on the y-axis, and then we're going to count the slope, the m, to find two more points. So we need a total of 3 points. We're going to determine if we need a solid or dashed line. We're going to shade, and then the last thing we're going to do is check our solution. Okay? Now the questions that we have going on today are just going to be ones that are already ready for us to graph. Okay? So we have y is greater than or equal to 2/5 x minus 3. It's already in y equals mx plus b form, so we're going to graph the boundary line. We're going to pretend as though that's just an equals sign. And in order to do that, we need to know what m equals, and we need to know what b equals. Remember, these are y equals mx plus b form. So when you graphed these in middle school, they needed to be in this form. Still the same case here. So our m is always going to be the number that's attached with the x. So that's 2/5. And our b is always the number that's being added or subtracted on afterwards. So that's our -3. We're going to start with the b. We're going to start at -3. And then we're going to count our slope. Rise over run. So up 2 and right 5. I'm going to put a dot there. We need a total of 3 points. So you can either count up 2 again and right 5. Or we could go down 2 and left 5 points, or 5 spaces. Now, you could make as many possible points as you wanted, so you could make another one over here if you wanted, but I'm going to ask that you have at least 3, okay? All right, now we have to determine solid or dashed. So when we had an inequality symbol like this before, when there was only one variable, if it had the equal to piece, what type of circle did we have? Closed in. Good. So now that we have a closed, we can't have closed in circles here, but now that we have an equal to piece, we are going to make this be a solid line. So we're going to add in here less than or equal to, or greater than or equal to is solid. Less than or just greater than is going to be a dashed line. Okay? So we're going to put in our ruler here. And we know that this needs to be a solid line. So we're going to connect all the way through the graph, putting arrows on both ends. Okay? We are going to shade. Now, in order to do that, we need to test a point. Okay? So the easiest point to test would be 0, 0. That means that we're going to test 0, 0. Okay? That means we're going to plug 0 in for y and 0 in for x, and see if this is a true statement or not. So this would be 0. 2/5 times 0 is 0, minus 3 is -3. So is 0 greater than or equal to -3? Is that a true statement? Yes, it is, which means we're going to shade on the side of the line that has that point 0, 0 that was true. So we're just going to shade like this. Okay, you don't need to shade in a ton, but you need to make sure that you're shading all over the graph. And then that was also our kind of checking solution. Those steps 4 and 5 go together. All right, let's take a look at another one here. So we have y is less than -1/3 x plus 2. So it's already in y equals mx plus b form for us. So we need to know what m is and what b is. So looking at our equation, m is the -1/3 that's attached to the x, and b is the +2 that's being added on after. We're going to graph that line. So we start with it, we begin with the b, and that's going to be the y-intercept, so we're going to go up to +2 on the y-axis. Our slope is -1/3, so we're going to go down 1 and left 3. Remember, it is rise over run. Down 1, left 3 again. You need to have at least 3 points. You can also go through and make as many points as you want. Okay, 3 is the minimum. Now, this has y is less than, so are we going to connect these dots with a solid or a dashed line? That would have been an open circle before. We can't do open circles, but we can do dashed lines. So every so often, you're going to just dash in on the graph. And then we're going to draw our arrows on the end again. All right, we're going to test a point. 0, 0, since it's not on our line, it's a super easy point to test. 0 is less than negative 1/3 times 0 plus 2. So let's see if this is a true statement. Negative 1/3 times 0 is 0, plus 2 is 2. Is 0 less than 2? That is a true statement, so we're going to shade down below that line. If this were a false statement, if this wasn't true, you would shade above the line on the other side. Both of ours have been true so far. So let's take a look back here. We can always test a point, but let's take a look back here for a second at these two before we go on to our next one. Here, this was a less than. Where did we shade in relationship to this line? We shaded below. If it is a less than or equal to, we're going to shade below the line. On the other one, it was y is greater than or equal to. Where did we shade in relation to this line when it was greater than or equal to? Above the line, okay? Above the line. So if it's greater than or equal to, you're going to shade above the line. So let's use that. You can still always test, but we're going to use that to graph this last one. All right, we have y is less than or equal to 3x. So we need to know what m and b are. So m is the number in front of x, that's 3. B is the number that's added or subtracted on. What's added or subtracted on? That's going to be 0. Okay, so your b value is 0 here. That means we're going to start at the origin. Our slope, now since this isn't a fraction, how do we make it be a fraction? Anything that isn't a fraction can always just go over 1. So that means we're going to go up 3 points and right 1. You're going to do that again, or you can go down 3 and left 1. They should all make a straight line though. That's what we're graphing as lines. All right, we're going to connect those. What type of line do we need to connect these points? Solid or dashed? Since it's got an equal to piece, that means that we're going to have a solid line all the way through your graph. All the way through your graph. Now, instead of testing a point, which we could do still, we're going to just use our knowledge from before. It says y is less than or equal to 3x. Less than or equal to. So from this line, are we going to shade above it or are we going to shade below it? Less than or equal to means we're going to shade below. Now I still will show you testing a point. Can we choose 0, 0 here? No, because it's on our line. So we would have to choose some other point. So I'm going to choose the point 2, 0. Again, you don't have to choose a point, but we're going to do that. So y is 0 and x is 2. So 0 is less than or equal to 6. Is that a true statement? Yep, 0 is less than or equal to 6. So that means that we shaded on the correct side of this. Okay, make sure you're following your steps. It needs to be in y equals mx plus b form first. Plot the boundary line exactly like you would do in the past. Make sure you're determining if it's solid or dashed, depending on if it has the equal to piece, and then you're going to shade depending on if it's greater than or less than. You could always test a point as well.